All right, whoa. Had a little bit of false start there. All right, everybody, welcome back to another dev stream for an indie game that we're making. I'm trying to remember what we're doing. We're making a game, and we're crazy enough to try to do it in a year. My name's Kevin. We're working on a combat platformer called the Rend. These dev streams are look behind the curtains. They're and kind of an open conversation, and one of the perks for our Patreon members that we share out over time. And today we're going to be rigging up a new character that came back. We're starting to get to that point where playtests are going, and we're getting to that point in the game dev process where really we have three big things left. Level layout, a bunch of art, which is the exciting part, and so we're going to take some time to rig up a new character that came back today. You will hear people asking questions along the way, things like that. I try to keep these compartmentalized into like 1 hour pieces that might be interesting or helpful in a sort of a standalone tutorial kind of way. And with that, thank you very much for everyone supporting the channel, for Patreon being the lifeblood of how this keeps going. And with that, let's get into what we're working on today. So, I said we got a new character back. It is part of our character voting. We are a little bit out of order, and that is okay. From the standpoint of the winner of everything was actually Rothkar, but we're actually working on Kael today. So let me bring that up. Users, and we're basically setting up a character from scratch is effectively what's happening. So we got a new model back. How does this usually go? Let's get this going. So we got Kael. Okay, so this is our character. Let me just double check. Yep, we got our stream going. Okay, this is our character modeled up.
Yeah.
Sorry,
and the stream is doing fine, but I don't actually see you myself. So sorry about that.
That's okay. I got you. Okay, so there we go. This is our character. Now, right off the bat, there are a couple things to note in the model, and I've already given a couple of these notes. So overall, we're using a pretty generic A pose. In a more traditional pipeline, where the legs are and things like that, we would be much more concerned about the exact posing of it. But because we're ultimately just using this as a render for 2Ds, I'm not super stressed about it, but we are going to do some comparisons to the owlbear here in a second. Couple things to note right off the bat. What are we going to do with this front loincloth? This scarf is super long, and the tail has a curved modeled into it. Ultimately, we don't want that, especially the curve modeled into the tail, because what that means is from a posing standpoint, from an animation standpoint, well, there's actually a bunch of reasons for this. Okay, so one, from a posing standpoint in animation, that means that every pose is going to be, you're going to have to counteract this arc, and we don't want to do that. That's one. The other interesting thing about having this like this from a deformations and character setup standpoint is when we go to bend the model, the layout of these very nicely laid out topology are already going to be pinching right off the bat. By having the tail straight, we'll be able to more easily see how our weighting is working in extreme poses. Whereas because there's already a bend worked into this, if the character bends the tail the other way, these points here, if we go into wireframe, these points here are going to get really, really far apart. And it just makes it a little bit more uneven as far as figuring out what the deformations are going to look like. That's still okay. We're still going to do a bunch of good work today on this. Like I said, I've already given those notes back. The big one being straightening out the tail. This we're keeping. We're actually going to keep this loincloth hanging through the floor because, well, we're going to see what the challenge of that is like, is basically it. And this is just part of the character's design. So first thing we need to do is let's save this guy out as a new model. We need to start building our folder for this. So our player character, we have an owlbear folder. This is going to be our Kael folder. Look, we already got one. We do need, let's see here, player, owlbear, 3D. So we'll do 3D. We'll just call it 3D. Okay, cool. This is a little bit unconventional, but that's okay. So new folder. 3D. And in here, we're gonna save this as Kael underbar, I think model underbar version 001. And I think this gets, I gotta remember how this pipeline works. Yeah, that's cool. And then we'll go with an ASCII file. I like ASCII files. If they get corrupted, there's at least a hope you can save it. But with binary files, you can't do that. All right, so let's save that. Now let's go ahead and set our project. So we're gonna set our project to be player, instead of player Owlbear 3D, we're gonna go player Kael 3D, select folder, create default workspace, that's cool. Then this right here, this is our character building tools. We've talked about them before in previous streams. Nothing crazy, it's just a procedural character build system. It takes a bunch of Lego pieces and lets you build a character. So I'm going to reset this. I'm going to auto find files. It found nothing. So we probably put the file in the wrong folder. So let's see where we put it. It needs to be in Kael 3D scenes. Yeah, we messed that up. New folder, scenes. And then this file needs to go in here. Okay, cool. So now let's go into here and let's open that file. Also, when we auto find, oh, actually, interestingly enough, turns out this pipeline uses Maya binary files. I forgot. So let's just save this as a Maya binary file. I never updated this pipeline. I probably should have, but do one more. Okay, so we got green, and green is good on the model file. We have no elements file, but we're also not done. We got a bunch of work here to get this kind of set up, and also I want to do some looking. I have some sneaky suspicions. So just for kicks, let's import. No. Let's reference in. Let's reference in the owlbear. So this is all of the standard work that needs to happen when you get a new character back. Hopefully, as your pipeline has matured, all of this stuff is kind of built in, and every model that comes back already has these things done. But in the absence of an actual pipeline, which is kind of more the Wild West of what we're doing, you can see right off the bat what we're dealing with. Okay, so especially when a model comes back, especially from freelance or something like that, generally speaking, if they're using Blender or something else, a lot of times the pivots and everything are not where they should be. So we don't want this character through the ground. So let's go ahead and take all of our Kael character. I'm going to group this into a folder called Kael, MD for medium res. And then let's move this up. Let's go to the front view. Go to wireframe, and let's get the feet on the ground. Okay, now, the other thing I kind of want to take a look at is, if this was a more traditional pipeline, there are a lot of ways this is often handled. The base pose, if you're doing actual 3D blending in Unreal Engine, etc., the closer these angles are to each other, the better the animation is resharing across characters, and the cleaner it is. Legs aren't too bad here. The arms, you can see, they're a little bit low. I would probably, if this was going to be an actual 3D, I would probably move these up a little bit. And I might even do that in here, just because, let's just say one day you all really love this game, and we're like, yeah, you know, what would a full 3D version of it be like? It'd be cool if we already had all the assets done. That would be sweet. And if we did it in a responsible way, it would make that transition a whole lot easier. So anyways, this move up looks good. We'll do the arm move later. A lot of times what I'll do is I'll do the initial skinning, and different rigging pipelines handle this differently. So what you can do is, and it may be worth me rebuilding the pipeline to handle this at some point, is, for example, in other pipelines I've built, there's the idea of a bind pose and a rigging pose. And the idea here is, this character could get bound with the arms down a little bit like this, but then what happens is when it gets exported and animated, they're moved up to more 45 degrees perfectly. That way when they go in engine, it all lines up and everything, and that gives you the ability to handle characters that are disparate. So for example, if you have a really obese character or they have a lot of armor like the owlbear and it needs more than 45 so that you don't have clashing, you can handle that. The pipeline can handle it. Okay, so scale, and the other thing we want to check here is scale. I think this is a reasonable scale to start off with. Kael is supposed to be, let me see, do I have a picture here? Did I download one? I don't know that I have the scale reference downloaded, so we may just wing it. I do have the pose reference, which is cool. This is what we want our character to look like when we're done. Okay, so we're just gonna go with that scale, that's fine. Now, we need a couple of other things. Let's, these all look good. Now that we've moved this, let's go ahead and group it one more time. And then let's freeze the transforms on this. So this is the new home for all of these meshes. Now, I probably want to make sure I probably want to give this information back to the modeler who was working on this, because I don't want to have to reposition it every time there's an update. Generally speaking, once we have the model update, we can handle things like UV changes, stuff like that. Point order changes start to become more expensive, but at least if they're in the exact same place, it's easier to handle. So I would generally take whatever changes I make here for a pipeline and rigging quality of life standpoint, and I would pass those back and say, hey, can we make sure our model comes in at that point? Some programs can't do that, like ZBrush, etc. Things are just like willy-nilly, and so it's an extra step that has to be done. But this is now frozen. It's in a good place. Let's go ahead and remove our reference. So we'll remove this guy. So we're left with just our character, which is what we want. And let's go ahead and save that. And then let's steal our owlbear skeleton. So we're gonna go back. I used to have fancy scripts. You know, at work, I don't do a lot of this stuff manually, where what I had was, I had a copy character script that would do this for me, but you get to see it done by hand. We're also not building so many characters that it's impossible to do this. So here's our elements. Let me just check that that's the, you know what, there's probably an easier way to do this. Let's just do this. Let's go owlbear. Actually, that's not easier. I lied, that's not easier. Here we go again, owlbear, 3D, scenes. And let's go by name, that'll probably be easier. And we're looking for the elements file, which is, that's anim elements. We do only have one, okay. And what we're gonna do is we're going to take our reference editor here, and we're going to replace this reference with the Kael model. 3D scenes. Let's get rid of this ASCII file just because it's gonna be confusing. We'll go with that. Okay, so now we have that. And then let's save this scene as Kael, 3D scenes. And this is going to be our Kael. Elements v1, save. And then when we do auto find files, we have green is good. All right, now what we need to do is, at this point, this is where the work starts. So couple things we don't need. We don't need the hammer, so we can ditch that. We're keeping the front cloth. Probably gonna oh, you know what? There's another change I want to make here. This is just because this is gonna be easier on our eyes. So let's open our model scene. Let's go back to perspective view in 5 and 6. This material is very hard to work with. We don't have our default colors or anything in here yet, and it makes it hard to see the geometry and what's happening and the flow. So I'm going to change this base color temporarily to something a little bit more usable. Let's see. I think, is it this one? No, that's Lambert. I'm guessing it's this one. So let's change our color. There we go. Let's do something more ZBrushy, and we'll go, let's just drop our shininess. We don't need any of this shininess. Oh, that's so much easier on the eyes already. Okay. And then what I like to do is I like to have a wireframe on shaded when I'm working so I can see this stuff. So let's save that, and then let's go back to our elements file, and we should have our pink. Cool. Okay, cool. And you can see in my elements file, I already have the wireframe on shaded. It just helps with placing joints and seeing things. Now, there are some things that are worth noting. Like, so for example, generally speaking, we like to have things like we mentioned with the tail, the cloths being straight. This one has a little bit of an arc to it. Not super stressed about it. It might be worth updating that to be something we probably need. We either need to separate these joints out a little bit further and space them, which could work. Go object. But at the same time, one of the problems with doing it like that and not adding more joints is it gives us less resolution to create the shapes that we might want in this loincloth. I am particularly curious about this from an animation posing standpoint, simply because what's going to happen is we may not be able to get we may need some more joints in here. The downside of adding more joints is if this was actually legit in engine, you know, you're dealing with joint limits and stuff like that. So back cloth, yeah, we're not going to keep, we don't have a back cloth, so let's just get rid of that. We'll delete that.
Don't you want to reduce the size of the front cloth? Can you do that later, or?
Yeah, we can do that later. So,
Okay.
It's a really good question. So, what's interesting about this front cloth is instantly, almost every pose is going to be fighting the cloth going through the ground. Now, I like to not have the technical or the hardness determine what the design is, as you know, where I like to keep an open mind about these things. And what I mean by that is, generally speaking, anybody who got this model back would look at it and say, oh, the front loincloth is too long. Why is it like that? Let's just shorten it. But I'm kind of like, well, maybe there's an actual thing there where it just is always dragging on the ground, or it kind of has its own life, and having that length there is important to do that. Now, there's an argument to be made here both ways. So once this thing is skinned, we could stretch it. We could actually, because it's connected to the joints, we could change the default pose so that it's longer. But the flip side argument of that is, once it's skinned, we could also shorten it. And in any pose we want, we could have it so that it is shorter and not through the ground. So I am intentionally doing an experiment with this. And it is very likely that as we start posing this character out, that this will drive us nuts, and we'll be like, no, we're shortening it by default. But I don't want to potentially take away the creative chaos that might happen as a result of having this long to from the get-go, is the best way I would describe it. Okay, so let's get the cloth, or let's get the leg joints sort of where we want them to be. Get the knee. Owlbear was so much bigger than this dude. We'll get all this stuff kind of in the ballpark, and then we'll start refining it. Nope. Alright, that's a little better. And this is our Kael elements file. Let's just go ahead and save as we go, just in case we have lots of fun. Now, in more seasoned and mature pipelines, a lot of this joint placement stuff can be taken care of more scripted. And what I mean by that is you can use tricks and stuff like markers on the geometry or geometry that shares certain attributes to automatically place all of these joints, so you're not spending all of that time. We do not have a mature pipeline in this case. We are running this lean, and we are also different. It's easier to control that kind of stuff when everybody's using the same kind of stuff, same tools, etc. These are different people who have different work styles that are contributing, that we have found, and so they all have different modeling setups, etc. So it's possible that I could have them all try to use more of like a universal topology, for example, and with that save a bunch of time in all the skinning and everything, sorry, in this joint placement stuff. But then we would also be paying more for them to spend the time to do that, and then you miss this exciting joint placement video that we've got going on right now. Who wants to miss out on that? Let's just see if we can start to get some of this stuff in place. Our owlbear didn't even have 5 fingers, so we didn't even have to place this stuff. Man, that seems like a lot of thumb joints. What joint is this? Thumb? Base? Yeah, this is a long thumb. All right, get this stuff in the ballpark. Just so it's not offensive. This is where all the time goes usually, in the fingers. So we're not gonna do this perfect. We're just gonna get it reasonable and started, and then we'll move on to the next bit of actually doing the weight painting. So we can start to move this guy. Fingers are hurting when you look at that, if that doesn't make your system think, ouch, that hurts, then okay. We've talked about this before. Base placement, where you place this within the mesh, can change how this deformation works. So if you put it right in the middle of the finger, it's probably easier to talk about when we get to the pinky. I'll do that. I'll talk a little bit about that when I get to the pinky. All right, so specifically what I was talking about there is, if we're looking at the edge of this pinky, we can place this joint kind of in the middle from the side view. Like this is this is the bottom side, the top side. We can place it in the middle. And what that means is the points on the top and the points on the bottom are going to move equally with the rotations. If we place it towards the bottom side, what happens is it's more forgiving on the clasp, but all of these points at the top are going to move way more because they're further from the pivot point. So choosing where in this meat of the hand this goes has an impact on how much you're working with the deformations and the correctives and things like that. And you can choose to favor it in different situations depending on what you're trying to do. Now, I totally messed this up. And this is actually supposed to be a metacarpal way back here so that we can do cupping. And this is supposed to be the bone that goes here. And then these are our digits. And I'm not sure if I messed them all up or just that one. No, just that one. Interesting, okay. These joints are quite large, which is making it hard to see everything. So I'm going to go to display and change our joint sizes to something a little more reasonable so that I can see what's happening a little better. Okay. Cool. This thumb piece I don't want here. Let's move it way back here. And also this. Oops. More down like that. Okay, cool. That's a lot more reasonable. What is this? Oh, that's the ring. Okay. So this is the metacarpal for the ring. So this is going to go here. And then if we look at this, we should be able to find the same thing for the middle. Okay, we're not too far off. And the index is, yeah, these are the metacarpals. This is what allows us to do the cupping. Okay, better. So let's see here. So the hands is definitely a lot of the time consumption. So let's get our spine going. Drop this up. We're gonna have to reduce a bunch of these sizes. All of these controls are owlbear sized. Which one is this? Spine B, C. Like, let's just get the head and neck in place. That's the spine end. And that's the head. So the head is gonna go right here behind the ear. This guy is gonna go just trying to get the spine inside the body right now. Undo. No rotations. Whether or not there should be a curve in the spine is often debated. I am not going to stress about it because of the game we're making. We just need good control, and we are going to get that. Also, the spacing and the thought process on how the spine gets laid out is I've seen spines that have every single spine joint that is anatomically correct in the control there's that many joints. And I've seen people space these so that the chest is one joint, because the chest moves as one piece because of your sternum and everything, rib cage, etc. It's very hard to bend it. With more joints towards the bottom, because more of the arc in the spine comes from that. I have found over time, for flexibility for animation, having an extra joint in the middle of the chest gives them the ability to bend that when they want to. And then they can determine based on project style what is best for that case. Oh, cool, we've already got ears. Probably use one more ear joint. So let's rebuild our ears. So the way that works is we've got our ears and we've got 3 joints. So we're gonna, not 34, let's go to 4 and then commit that, and that gives us an extra joint to work with. So we'll take that one, put that up here at the top. And there we've got something going for our ear. I'm probably gonna move this up a little bit. If it's too deep, it doesn't do anything as far as giving us control over the shape. Okay, that looks pretty good. Arms look pretty good. Front loincloth looks good. We need a scarf. So let's add a scarf. How are we doing for time? All right, we'll add the scarf, then we'll try a build, and we'll see about getting some skinning going. So let's do this. So we need a new, and we're gonna use custom, and it's going to be called scarf, and it's gonna be center with no mirror. We'll try 7 joints to start with, and let's create that. Okay, so where did that go? Here it is. So let's move this up and get it in place. And these are going to be, let's get a starting point. So this is -90, 0, and 180. There we go. We'll put our base point here. That looks good. Frame on that in here. Open that up. And this is the other nice thing about having this stuff modeled straight. I can just take one quick select of all these joints, and they spread out nicely and evenly. Now, once again, per our previous conversation, when you look at things like scarves and tails, etc., a lot of the extra bend and flex comes at the tip. So a lot of times it's worthwhile to, so like, let's just do it. Let's refresh this. Let's take our scarf and we're gonna add, let's add 2 more joints to this. We'll commit that. And what we're going to do with these joints is we're going to make these, we're going to add a little bit more of an exponential fall off towards the tail of this.
So since this is a piece of cloth, I suppose you could go wild and add a ton of different joints. Where do you set yourself the limit between like wanting to have like more flexibility and reduce the amount of headaches to having to deal with all those joints? Where do you find the balance?
Generally speaking, I want enough joints to create the shape that I want. So the broad shape that I want. So for example, things like scarves and tails, that means the minimum is usually 5 joints, because you can't make an S with 3. So generally speaking, that's kind of how I start it. And then as far as like why not have like 20 joints down the length of this, it's too many to control. And there are very special cases where you have insane number of joints to do things like a specialized tentacle that has the ability to delicately pick up a set of keys or something like that. You just need the fidelity to do that. But you also may not want that as your primary rig, and this applies in both film and game. You may want that to be a one-off rig that you use for just that one thing. So by adding some extra joints here at the end, what that means is I can get a nice tighter arc at the end, where at the ends of your overlap motions, you can get that nice flick back if we want it in the scarf. The other thing is, joints are more of a broad stroke way of kind of handling like the overall shapes of cloth and physics and stuff like that. If you want real cloth, you end up, it doesn't matter how many joints are in it, you end up using sim in engine anyways. So that's just kind of the way I've generally worked. This is a long distance from here to here. Usually I like to have a shorter so that I can create a bend that will allow this scarf to rotate downward. Yeah, to allow this scarf to rotate downward and come around, like for example, come around the scarf or go above. Like if I wanted this scarf to come up here, like in this arc like this, I want to be able to bend it. So I'm gonna kind of shorten that a little bit. And then that's obviously gonna have a knock-on effect down the line. Okay, so we got our scarf. Now, the scarf doesn't have a parent yet, so we do need to give it a parent. So let's do that. Let's take, this is gonna be spine end. We will make that the end for the scarf. And, okay, let's save all of that. And then let's take all of these, scale them down a fair bit so that these controls aren't just gigantic. A little better. So these are just the control handles that, you know, animators grab to do the work. And these are the FK ones, so we'll align these to the actual deal. And oh my goodness, what is going on with these arms? Okay. Whew. I feel like I can breathe again. Okay, so this is a pauldron. We do not need this pauldron. Let's delete this. And then this is our shoulder control. Let's take this and move this in place. This is another shoulder control for our FK shoulder. Yeah, we can shrink that up, that's fine. Head, etc. Is this the actual head? Yeah, let's move this up so it's always visible all the time. Let's bring this forward a bit and shrink it. Okay, I think we have a reasonable layout. Now, here's the trick. At this point, we should be able to build the control rig for this. I'm curious. Let's just try a manual build real quick on the control rig. So to do that, let's hide all of our elements and let's just build the anim rig. It's thinking. There we go. One control rig. Now, these are facing the wrong way, so we'll have to fix those and stuff like that. This is part of what I wanted to do is build this and see. So we got a couple joints that are kind of facing the wrong way. That's probably, we just need to do a rebuild. So if we open this back up, let's take a look at our spine. And we'll take a look at this guy and we'll commit it. And then that's gonna be that. So let's save that. And then for the ears, where's our ears? Here's our ear. There should be, look at this. So this, wait, what is? There should be an orient control for this ear. Here it is. Where is this? Ah, it's over here. So let's move this. This determines which way the ear is pointing. So we'll do this, I think we'll do this forward. Okay. And then we have all of the hand, all these joints will eventually determine which way the fingers bend. So I like to move them a little bit more in line with where they're at. So this is our middle finger. This should be our ring. It is. And this is going to be our pinky. Okay, and then this is still our middle. This may be our index. It is. So what these do in this particular rigging system, and different rigging systems handle this differently, these are used as up vectors. And what I mean by that, is it still in there? Okay, you can see there is a ring, this ring right here, that's on the finger. And this defines the plane that that finger is going to bend in. And when I move this, do you see how that ring rotates? That is what is determining the bend direction for each of these fingers. So what I'm looking at when I do this is that this ring here, which is usually a hot pink, I don't know why it's very obscure, dark, whatever, is the right direction. So for example, this thumb is going to bend the wrong way compared to where a thumb bends. We don't want it to bend that way. We want it to bend in the direction of a thumb. Okay? So that should be that. Cool. We're probably going to have some work to do in this knee because the knees and the arms are different. They're determined by the plane defined by the 3 joints. Ooh, undo. And as a result of that, there's a little bit of guess and check in getting the plane to be the plane that you want this hand. And what I mean, oh no. Okay, whew. I thought we had done one of those ones where you can't get back. Okay. And so what I mean by that is if we save this and we build this rig again, I'll show you what I'm looking at. And the idea is that when we bend the arms, they should bend in the plane that's defined by the shoulder, the elbow, and the wrist. Okay, so when I pick this FK arm, you can see, this is actually pretty good. You see this, what I'm looking at is, if you look at this, where'd it go? If you look at this manipulator here, there's 3 different colors, blue, red, and green. The red circle, this red one here, that is the plane that this arm rotates in. And when we rotate the arm in that plane, it bends towards, if your arms were there, towards the face. That's what I want. So that plane's pretty good. Let's check the knees. Usually you'll get weird bends if they're messed up. So this is probably more than good enough for what we're doing on this project. We will flip these around. I believe, here, let's see. Z is forward on this rig. Let's check that against the owlbear and make sure it's okay. So we're gonna open the owlbear real quick. and that's going to be I believe it's the game rig. Game rig version 5. Don't, oh, dang it. Don't save. I just want to double check that these are Z forward. Okay, but so the handle, you can see which way the manipulator is facing. Oh, actually that's in world speed. You can see which way the manipulator is facing, that's good. But the handle's independent. So the handle's just a visual that lets you pick it. Okay, so now that we have that, now we actually start the work of getting the character to move with the controls. And that is, what that entails is some tagging. We got to tag each of these pieces of geometry for this particular pipeline to explain which pieces it should all move with. So let's open up this owlbear model and let's steal some stuff. So we need our deform by GUI, and this piece, I'm going to get this selected. What does that say? Ah, here we go. That's what I want. Cool. Use selected geo. And this thing is called, what is this thing called? Body LP. That's going to be important here in a second. So let's memorize that. And then I'm trying to think on that character we had. No, I think that might be enough. Let's go back to our character now. And in this case, we're going to go back to our model file. Okay, and I'm going to rename this body. And I'm going to call it body, temporarily, body LP to match. And then I'm going to apply this to the model file. Oh, however, we have a problem. So now, so what that does is that creates a tag. And the tag, if we bring up the attribute editor, gets applied to the mesh, and it gets put in here as the joints that deform this. Okay, so let's do something here. We're going to create a new file. We're going to paste this in, and we're going to do a quick search and replace. Search and replace. I am not, there it is. And we're going to replace owlbear with Kael. Now, also really good discussion to be had here. This is why there's arguments to be made about using prefixless workflows. So this thing isn't called Kael underbar body. It's just called body LP. And the joints aren't called Kael underbar joints. They're just called neck A, neck B. So this is a super old pipeline that I'm using. So it's worth calling out some of like those long-term learnings of potentially why you wouldn't want to name all of your joints to have the name of the character in them, as an example. Also, for when you have multiples of the same character in the scene, it's a whole lot nicer if you can just reference them in with whatever the prefix is, as opposed to having double prefixes, as an example. Okay, so let's save that. So we'll save this, and then let's use the selected geo. Cool. And then let's, actually I want to, I'm trying to remember how this works, so give me a second. I see. So there's pants, legs, boots, Okay, so let's go back here. Let's reopen. Did I save this thing? Hold on. I did. Oh well. Okay, so let's just start we're gonna just lazily tag all of this stuff the same, just to kind of get through this. And see if we can get a skin pass. Okay, and then the scarf we're going to do separately, and the tail separately. We haven't even created the tail yet. Okay, so let's apply this to the model file, and then let's reopen this, and let's use selected geo, and then let's memorize and apply that just to make sure we have the same thing. Okay, so save. Okay, so theoretically, can we run a build? We are at 4 minutes to 1 hour, and we've tagged our geometry. Let's see if we can do this. Auto find, those are all the same. Execute build. Wait, no, let's save this scene real quick. Execute build, go. This will be awesome if it works. Okay, so what this is doing, just to kind of walk through, is a procedural build. What it does is it goes out, it gets the model file, then it gets the rig file, then it combines the two together, then it looks for default skinning, default settings, all those things, sets it up, builds the rig, skins the character, and then spits out the other side an animation control rig, a Unreal Engine skeleton that you can import into the engine, and a game rig that uses that Unreal Engine skeleton. And what you end up with in this particular case is a game rig. And look, the character moves. That's cool. Okay, so obviously we have some skinning problems, okay? But the character does move. Now, one thing that's wondering is spine A. The spine A. Oh, okay, so we do have a problem. Oh, it's interesting. All of our spine joints are facing backwards. That's interesting. So we'd want to fix that. What we can do is we can kind of start culling this and cleaning it up. So, for example, do we have any skinning tools? We do. What we can do here is we can take our skinning tools and we can go ahead and initialize the skinning for this, and then we're not using interesting. Let's see something here. Actually, that's not horrible. Let's see here. Show. Use data.
Ask a question about the procedural skinning, or you want me to wait?
Yeah,
till
of
the
course.
end, or?
No. You throw them in as you go, as we go.
Yeah. So, does it just pick? Does it just go through the vertices and pick up bones by distance, or does it traverse the bone hierarchy?
Okay, really good question. So that is actually a setting that you can choose, and it's probably worth talking about. So by default, in most skinning setups, this is like, I brought up the interface because it's easier to talk through. Also, what's up, Narota? Good to see you.
What up?
The way these generally work is you choose whether you're binding to the whole hierarchy or just what you have selected, and then you choose the bind method. In this case, to your point, what it does is it uses closest distance by default. So for each vertex, it finds the joints that's closest. But there's a lot of people who've tried to get super creative about this stuff. And what they'll do is, so there's different methods: closest in hierarchy, heat map, and geodesic voxel. So the way each of these algorithms work is more and more complicated. Like geodesic voxel takes longer. It does generally a better first pass job. However, in my experience, what I found is it ultimately puts small amounts of weights on things that I end up having to clean up anyways. So I generally have found, and we talked about it once in one of our previous skinning things. What I found was a lot of times it's just easier to do more like a rigid bind type setup. Which actually looks like what we've done here. We do have a rigid bind. Okay, so, and then what I do is I'll go through and paint and control what I want afterwards. So for example, right now you can see these ring tips. If we look at this, so the answer is it depends on what you choose. There are different methods. I believe there is a world coming where AI will be able to do this so easy. As a note. But in this particular case, we have ring, because the ring finger is closer to this piece of cloth than the up leg joint. You can see it got bound to the ring finger. So I'm just going to go through and flood replace that. So our ring finger isn't actually doing anything on the, like nothing in the upper body should be affecting these pants. So like tip and mid. And spine A is fine. So that looks good. So now when we grab these, still getting some ring finger in there. Possibly because, let's just take the left hip here, paint this. Oh, interesting. Left up leg? Yeah, okay. Oh, no. Not replace, add. Actually, let's replace. Oh, sure, we'll just add one. That's fine. Okay, so that does that. So just make sure. And then what I'll do is so now what we're gonna spend the next hour doing is I will take and I will animate a couple little poses that I can just check what I'm doing. And then I'll go through and I will fix all this stuff. So the skull, initialize skinning. This thing should just move with, it definitely shouldn't move with the wrist. Right? And I forgot, it's interesting, oh, we're not distributing. So because we used a solid bind, these aren't going to where they should go. So let's just go with this on the left hip and we'll add flood. So that
looks like the bracer is not moving with the wrist either.
Yeah, so it's another one. Actually, we didn't bind it. It may not even be bound. Yeah, there's no skin cluster on it because I missed, when I did the initial tagging, I missed that was a thing. So what we could do here is, let's just do this. Oh, my joints are hidden. Too fancy. We're too fancy here. This may be a pain to show the bones. Yeah, let's see. Do I have a script left over? Graph editor. I do not. Okay, we'll just do the hierarchy check. Pelvis. So I could just skin them in here right now. And then what I'll do is I'll memorize those and add that. The trick here with the way this is set up is you have to remember to go back and re-tag the geometry. Now, what I'll do is I'm not gonna bore you with going through all this, but what we're gonna do is we're basically gonna iterate on the weights, okay? And what I'll do is I'll save this scene. I'm gonna save this scene as the game's the game skin version 1, so that I have this. I can make my changes, and then I can rebuild the game rig and make sure it all applies. And if I accidentally miss something, I can go back to my temporary skin file and get and so for example with the bracers, if we went ahead, just to finish out that thought before we wrap up, if we take the low arm, which is this one, we could probably just bind this straight to the low arm, all of these. So Naroda, to your point, when we go bind skin, selected joints, closest distance, apply, what that does at that point is that makes it so that it's 1-to-1. I missed one. Which one did I miss? This one. Bind skin. Okay. Cool. So the bracers there. You can see we missed these guys. So these are going to be probably left clav and right clav, for example. Bind these. Cool. And what the heck is this thing? Oh, those are eyeballs. Oh, we need those. So we'll bind these to the head. All right, there we go. And then the scarf is gonna get bound to the scarf, which is here. So we pick all of these scarf joints, and then the scarf, and then we can bind the skin there. Okay, now this is probably a good example to show you to finish my thought. What? Oh, I know why. Because this is actually controlled by controls that we're not seeing. Okay, so right now, when we bend the scarf, look at how rigid this is. It's like a 90-degree angle. So the settings that I chose when I bound this rig, I forgot to check them. And they are set for 100% weighted to every joint. And the reason for that is what we've done in the past is you can do, if we take this, we can put a deformer on this, which is called a Delta Mush deformer. And what it does is this is like a fancy preserved volume and nice bending thing. So look at the bend now that we get. But the weight is still 100%. I've just added an extra deformer on top of this. So by doing that, it's easier to potentially control, and I get this nice arc. But if you look at this shape without the Delta Mush deformer, see how rigid and square each of these bends are? So that's just like trickery with understanding how this works. And the reason I'm mentioning this is it's a methodology thing. You could rig like this with rigid. Everything's very clear what it moves with. And then what you do is you can then take what this Delta Mush deformer is doing and bake it down to the base skinning level. So you don't need the Delta Mush at all. So when you're using a tool like Maya, what you can do is lazily paint your weights so they're rigid. Use a cool deformer like this or any trick you want so that when the knees bend, etc., they look good. And then you're like, okay, great, I want to bake that into the base skinning that goes to Unreal, for example. So, yeah, that's what's happening there. But I'm going to keep this as rigid for now. We'll zero this out. And then does our scarf. Yeah, so now our scarf moves. Cool. So same thing over here. What we'd do is we'd take our skinning here and we'd take our right up leg and paint that. And these should be moving with our right up leg. Right? So go through, fix all these things. That's kind of the deal of what's going to happen over the next hour or so. I'm not going to bore you all with all of that. Let's see. Oh, undo. Jeez Louise. Let's see what our elbows look like just for kicks. Okay, so they're not terrible, which is hilarious to me. How are they preserving volume? This is another great example. Like, for what we're doing, because this is all going to get into 2D, I'm okay with this crashing because it's preserving the volume. Like, I'm okay with that. But if we wanted to see what that looks like, just on our kind of on our previous conversation, if we take this and we zero this out, let me grab these guys and delete this keyframe, and then let's add a keyframe here to go to 90 degrees. Obviously a bunch of stuff that needs to get clean, but if we take this, we go back to frame 0 and we create another one of these delta mushes. Watch what happens as the elbow bends. As this comes in, you can control like what the elbow does at the seams. Like, we can kind of tweak how this happens. So let's see here. So as you see, this is kind of coming through. You kind of sculpt how this happens in the crease.
You can simulate muscle flexing, or is that something else that you would do?
That's probably something else. This is just more like a volume preservation thing. But if you look at the way this bends here now versus without it, see how it's rigid, it just goes straight through. If I turn on the Delta Mush, it kind of preserves that shape a bit better. And you can do this with just more traditional skinning and things like that. But the cool thing is, for this project, because of the way we're rendering it and building it, I am not stressed about that. The elbow preserves its volume, and when this gets rendered in 2D, it's gonna look sick. I'm not even worried about it. Okay, but from a just a general understanding standpoint, that's where we're at. So this is the skin rig. I'm gonna save this, and let's call that a non-blue screen of death stream so far, right? Like, that's good. Hopefully I have the volume on YouTube, because that would just be the killer. So the point here is, at this point, so we got another new character back, which is exciting. Generally speaking, just the art is exciting, and this phase that we're coming into is going to be cool, because we're building the characters, we're bringing them to life. We're building the environment, we're building the level, we're adding the encounters, and this is just like all the like super high creative stuff. So from a skinning standpoint, that's just a quick, our little bit much demo of how this particular pipeline goes through, a look behind the curtain as to how you approach skinning. And then I'm just gonna go off and paint, basically get this so that it all looks good. For us to be able to render and start posing the character, and maybe next stream we'll do some animations or posing, or I'll show you how to steal animations from other characters or something like that. We'll figure it out. Before we wrap up the stream and just hang out for a little bit, did you all have any questions for the stream itself?
Nope.
Okay, cool. Everybody else, as always, if you haven't playtested the game, it's there. The links are in every video now. We're getting ready to release our legendary mode, Distorted Weave. Playtesting the game helps. It helps us know whether or not we're making something that you guys are excited to play. It also helps us find bugs and issues and stuff like that. As always, thank you for supporting the channel. Thanks for spreading the word. My name's Kevin. Hope you have a good day. Take it easy.